All right, here we go. So our objective is to apply segment and angle addition postulates. So make sure you write the top learning objective. You're not writing the language objective on your warm-ups, okay? Though of course you do want to be able to justify your answers in your words or your out loud. Okay, so again, we're supposed to have a quiz tomorrow on constructions, test Friday on Unit 1, and the assignment from yesterday is due soon, so make sure you get that done. Now, I know we already said this, but I'm just recapping because I have to get this on the record here. Number one, when you have two x's on the same side of the equal sign, you combine like terms. So 3x plus 2x is 5x. You bring down plus 30. You bring down equals 180. This is a two-step problem. We've already talked about this, but when you have a two-step problem, you get rid of the loner and then you divide. So the loner on the side with x is 30. How do I get rid of a plus 30? The opposite, minus 30, minus 30. Okay, so cross out the opposites, bring down 5x equals, and 180 minus 30 is 150. Last step, to get rid of a coefficient 5, that means 5 times x. The opposite of multiplying is dividing. So you do divide when you have a coefficient in front of that x. Those 5's cancel out. 150 divided by 5 is 30, okay? That's when x is on the same side. You can combine on the same side. Now, number 2, we have two x's again, right? But this time, one's on the left, one's on the right. So what do we do when they're not on the same side? You said it earlier. Okay, you can't have two x's and they don't combine, so you have to get rid of one. Okay, you get rid of the smaller x. Which x is smaller, 3x or 7x? 3x, and it's positive, so how do I get rid of a positive number? Subtraction. So the opposite of positive 3x is minus 3x here. If I do it on this side, I do it on the other side, minus 3x here. Let me zoom in a little bit. So the opposites cancel out. Now be careful here. What am I bringing down right here? Okay, and it's not just 4, it's got a negative with it. Okay, negative 4 equals, what's 7x minus 3x? 4x, and then you bring down this plus 16. And you got to get really familiar with this. Now we have a two-step problem. You get rid of the loner and you divide, okay, every time. So x is on the right side. So on the right side, what's the loner? Does everyone see the 16th by itself on the side with x? So we get rid of a plus 16 with a minus 16 on this side and this side. Cross out the opposites. Now negative 4 minus 16 gives me negative 20. And if you're not sure about that, if you're not good at adding and subtracting positive and negative numbers, let me show you on your calculator. You could have typed negative 4 minus 16. It tells you, right? So these yellow calculators are your friends. Get used to them because you cannot use your phone as a calculator anymore. Just saying, if you ever did. So last step, to get rid of the 4 coefficient. The 4 in front of x, how do I get rid of it? Divide. And then negative 20 over 4 is negative 5, okay? You're going to be doing both types of those problems today on these notes that you grabbed on the way in. Everybody grab one of these notes on the way in. Right here. So, for today's warm-up, again, give you 20 points if you wrote your objective and you wrote the warm-up, okay? You put the warm-up sheet away, and let's talk about these notes. All right. Oh, there it is. Okay. Sorry. All right, here we go. Everybody with me? So, you're looking at this sheet. We're talking about two postulates, angle and segment addition postulates. So let's read it real quick. The segment addition postulate states that if we're given 2 points on a line, segments, points A and C, if a third point B is on that segment, if and only if the distance between the points meet the requirements of AB plus BC equals AC. Now, that's one way to put it, but simply on these blanks, go ahead and write this down. Whenever you have a segment that has two parts, the one part plus the other part added together equals the whole thing. Part plus the part equals the whole thing in a segment, okay? They're going to take all class. You might want to go real quick now, or you might have to wait till passing period. I'm sorry. Do you need to go? Wait, what? The notes are going to take all class, I'll be honest. So we'll have a little bit of time at the end. All right. So now for angles, so that was for segments. The part plus the part equals the whole. What about for angles? Same thing, okay? If you have an angle ABC, D is between it, then ABD and DBC add up to the whole thing, ABC. So once again, part plus part equals the whole. I hope you get sick of hearing that today, because you understand that the part plus the part equals the whole, okay? So let's see how that works out. On number one, there's no picture. Sometimes you got to draw a picture, right? So it says R is between FY. So everybody, go ahead and draw. Doesn't have to be a perfect line, but go ahead and draw FY. So F's on this side, Y's on this side. And do you notice how it says R is between? Good question. So here's the deal. When it says between, that does not always mean exactly in the middle, okay? If it wanted to be in the middle, they would have said midpoint, okay? So what you can do, you can put a little bit off center. Doesn't need to be perfect, okay? That's your R. R is between FY. You got to be able to draw stuff like that, okay? Now let's label it. It says FR, for real, is 3x minus 2. Let's go ahead and draw that. 3x minus 2 is FR, for real. Now, then it says RY is 4x plus 7. So let's label RY 4x plus 7. So would you agree those are the two parts? Now we need the whole thing, and it tells us FY, which is all the way across, is 96. Okay, so now I have a picture. It has a part and the whole thing. So now I can use what I wrote at the top to figure out x, okay? So go ahead and write part plus part equals whole. That's my equation that I'm going to use. And let's plug in the first part. You tell me, what's the first part, FR? Okay, let's write 3x minus 2 plus, what's the second part, RY? 4x plus 7. Perfect. And now I just got to put, what does it equal? So what's the whole segment FY? 96. Very good. Half the battle is setting it up. But if you remember, part plus part is whole, that'll help you get there. Now, this reminds me of my warm-up today. Okay? I got to think about, are the x's on the same side or on different sides of the equal sign? And what do I do with it? So first of all, notice equal signs right here. Sorry. So the x's are on the same side. They're both on the left and equal. Do I combine them or get rid of one? What do you think? Same side, combine. Okay. They're both to the left of equals. I'm going to combine those x's together. What's 3x plus 4x? Okay, 7x. And do you see how the -2 and the 7, they're both numbers. Those are like terms. Those match. Okay, so also if you have just constant numbers sitting there on the same side, those can also combine. So it's negative 2 plus 7, or 7 minus 2. 5. So plus 5, bring down equals 96. And like I said earlier, you got to get used to these two-step problems. You get rid of the loner and you divide. Okay? You got a phone in your hand. I want you to be writing this down. There's too much to write to be having a phone in your hand. So we get rid of the loner, the plus 5, by doing the opposite. What's the opposite of plus 5? You want to put minus 5 underneath that plus 5, right? So let's write that down. Minus 5, minus 5. Bring down 7x, and 96 minus 5, 91, okay? Last step, to get rid of that 7 coefficient. Again, we divide. Divide by 7. And again, your calculator can help you. What's 91 divided by 7? I don't know that off the top of my head, but my calculator does. So it's 13. Okay, so x equals 13. Wherever you want to write that, that's fine. Try not to encroach into number 2 too much. Okay, number 2, same idea. I know my first part, QR. I know my second part, RS. But the question is, do I know what QS is? It's not on the picture. But if you read, it says, blah, 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 blah. Hey, QS is 15x plus 2, right? Sometimes you do got to read. It gives you information in the instructions there. So QS is 15x plus 2. Okay, I have a part, I have a part, I have a whole. What's my equation? What do I put? So you're one step ahead of me. So now you don't have to write this every time, but I'm going to do it for now just because we're learning this right now. But it's part plus part equals whole, right? Part plus part equals whole. You've heard me say it a million times, not really, but many times, and I'll keep saying it. The part plus the part equals whole. What's the first part? QR. 5x minus 2. The second part is just 10. And the whole thing is what? 15x plus 2. Cool. What could I combine in this equation? Okay. The negative 2 and the 10 are on the same side. Those are constants. Those are numbers. By themselves, they can be combined. Negative 2 plus 10 is, or 10 minus 2 is 8. Okay. Let's bring down that 5x in front of it. Don't forget the plus sign because it's positive. Let's bring down 15x plus 2 on the other side. Now this looks like the second problem from our warm-up. Okay. These x's are not on the same side of the equal. 5x is on the left, 10x is on the right. So I don't combine them. I get rid of one. I like to get rid of the smaller x, which is 5x. How do I get rid of a positive 5x? Subtraction, right? So minus 5x minus 5x. We bring down 8 equals 15 minus 5. 10x, and then we bring down the plus 2. Once again, we find ourselves at a two-step problem. You got to be like pros at two-step problems. You get rid of the loner and you divide. What's the loner here? 8 looks like it, but you think of the side with x. So x is on the right side. On the right side, what's the loner? 2. So let's get rid of that positive 2 by subtracting 2. Okay. 8 minus 2 is 6 equals 10x. Last step to get rid of that 10 is dividing by 10. Now 6 divided by 10 does not give me a whole number. In fact, if I were to type it in my calculator, it would only reduce the fraction. That's fine. 3 over 5, that works for me, okay? All right, so that's segment addition postulate. We're gonna get to angle addition postulate in a minute, but when you flip it over, we need to talk about numbers 3 and 4. 3 and 4 are kind of a throwback to something we talked about already, but we haven't used algebra. You can, just gonna miss some stuff. So I'd go real quick. All right, number 3 on the back. All right, I'll be impressed, and maybe I have a prize for you. Does anyone remember the name of these angles when they're across from each other? Anybody? It's kind of close, but no. Inverted? No. So, and those are both kind of close. They're called vertical angles, okay? Now it doesn't make sense because they're not always up and down like a vertical line, okay? But they are across from each other, okay? So do you see how both of these, like this is across from this, right? And for number 4, this is across from this. So it doesn't matter if they're up and down, if they're across from each other, they're vertical angles. You can actually fill that in already if you want. These are vertical angles. These are vertical angles, okay? Now we're gonna make a little note for yourself at the top. Vertical angles are congruent. Congruent means they're the same shape, same size, equal measurement. So what do? You set them equal. Okay. This is important. We're not doing part plus part equals whole. We're not doing addition postulate because we know they're the same. If they're across from each other, you know they're the same. All you do is put an equal sign between them. Okay. The vertical angles, set them equal. So that's what we're going to do. Number 3, let's do it. 6x minus 12 equals 3x plus 18. I know they're just equal to each other because they're vertical angles. This is like the second one from the warm-up. You can't have x on both sides, so you get rid of the smaller x. Which x is smaller? 3x. Let's get rid of a positive 3x by subtracting 3x on both sides. I'm left with, once again, 3x. Bring down minus 12, bring down 18. And again, by now you should be very familiar with these two-step problems. You get rid of the loner, the minus 12, by adding 12. 3x equals 18 plus 12 is 30. And then your last step to get rid of that 3 is you're going to divide. Okay, divide by 3, divide by 3. X is 10. Number 4 is the same idea. You set them equal. 9x minus 10, 8x minus 2. Why are they equal? They're vertical angles. They're across from each other. Again, x can't be on both sides. We get rid of the smaller x, which is 8x minus 8x on both sides. Now, 9 minus 8 is 1. You can write 1x, but usually 1x is just x. Bring down minus 10, bring down negative 2. How do I get x by itself? How do I get rid of a minus 10 next to it? The opposite is to add 10. Very good. So negative 2 plus 10, or 10 minus 2, gives me what? 8. So you can fill it in the answer blanks too. X was 10 over here. X is 8 over here. So when you see vertical angles across from each other, you have to set them equal. Solve for x. Now last two, these are angle addition postulate. Okay? So I'm telling you on these last two, when you have a part and a whole thing, you got to do angle addition postulate. So let's label what they give us. It says PLV, from P to L to V, is the top angle, is 3x plus 2. Go ahead and fill in that first angle on top is 3x plus 2. Then it says VLM. So from V to L to M, that's the bottom angle, is x minus 5. Go ahead and fill that in. So we have two parts labeled. Now, the last thing it says is PLM. Watch this. From P to L to M, that's the big whole angle, okay? So, to label that, here's what I like to do. I like to put a big arc. That's the whole angle is 125. So again, we are doing part plus part equals whole. The smaller angle plus the other smaller angle equals the whole big angle that consumes them all. So let's write that as an equation. 3x plus 2. That's the first part. What's the other part? X minus 5 is my other part. Add those up, equals the whole thing all the way across we wrote is 125. Okay, this is like our first problem from the warm-up. Two x's on the same side. Do I combine them or get rid of one? We combine them on the same side. 3x plus 1x is what? 4x. Also, I have constants I can combine. 2 and minus 5. What's 2 minus 5? If you're not sure, again, your calculator can help you with little things like that. 2 minus 5 is negative 3, so we'll put minus 3. Equals 125. We bring that down. And we have a two-step problem. Again, get rid of the loner and divide. What's the loner that I'm getting rid of? The minus 3, what do I do? Plus 3 plus 3. 4x equals 128. Last step to get rid of that coefficient in front being multiplied, the opposite of multiplying, I got to divide. So 128 divided by 4 is 32. Now, real quick, they're asking what the angle pair is. The only thing I know about these two angles is that they're next to each other. Y'all remember the name of angles that are just next to each other. Starts with an A. They're adjacent. Yeah, that was from like the first week vocab. Y'all remember that word, adjacent? It just means that they're buddies next door to each other. ADJACENT, adjacent. Okay. Last one. I'm sure you're relieved. There's a lot of stuff to put down at once. So I see two parts. I have my first part, 2x plus 4. I have my second part, 2x. But here's the question. What's the whole thing? Y'all see how these two angles make a straight line? Do we know how many degrees a straight line is? Okay. It is 180. You got to know that if they don't give you the whole thing, but it's a straight line, you're supposed to know 180. Okay? This one wasn't. This one is because they make a flat straight line. Real quick, when two angles make a straight line, we call that linear pair. Okay? So you got to know that. Two angles that make a straight line are a linear pair. And together they make a straight line of 180 degrees. So once again, part plus part equals whole. 2x plus 4 is my first part, plus 2x is my other part, equals a straight line. The whole thing is 180. Okay? So let's combine terms on the same side of the equal sign. 2x and 2x is 4x. Bring down plus 4 equals 180. And again, two-step problem. You get rid of the loner, and then you divide. The opposite of the plus 4 loner is to subtract 4. I get 176. And then to get rid of the coefficient 4, I have to divide. 176 divided by 4 is 44. Okay? On all of these, you could conceivably plug the x back in to find the missing angles. Just saying, okay? But we have done segment addition postulate, we talked about vertical angles, and we talked about angle addition postulate, okay? Now with our little time left, if you didn't finish the construction assignment from yesterday, there's your tools over there, you can work on that. If you're done with that, or either way, you need to hold on to this. This is your next assignment based on these notes, all right? Here we go.